Hi, my name is Jakub Szymaczek and I'm a program manager in the SQL engineering team at Microsoft. Today I'm excited to show you how easily and effectively you can secure your data in Azure SQL Database using some of the advanced and intelligent security capabilities we have recently introduced. In Azure SQL Database, we think about security in terms of layers. In the center, you have your data. And the first layer aims at protecting the data itself, typically by using encryption. The second layer is how you control who can access which parts of your data. And the outer layer is how you monitor access, tracking the activities that happen in your database, and how you manage security and security policies in your database environment. Azure SQL Database has multiple features in each of these layers. In this short presentation, I'd like to focus on some of the newer, advanced, intelligent capabilities we have recently released. So first, let's talk about the innermost layer, data protection, which is about encrypting data to ensure it's protected as it moves across your application stack. For example, encryption at rest is a common requirement imposed by many compliance standards. And in Azure SQL Database, Transparent Database Encryption, or TDE, is a recommended solution for encrypting your data at rest. Recently, we enhanced TDE by adding Bring Your Own Key support to allow you to choose your own key in Azure Key Vault and use it with TDE. So with this enhancement, you can control who can access your keys and how you can rotate them on your own schedule. Another encryption feature I want to call out is Always Encrypted. Initially released in 2016, Always Encrypted laid the groundwork for transparent client-side encryption that protects sensitive data in use from high-privileged yet unauthorized users. We are now bringing this exciting feature to a new level by incorporating a cutting-edge technology called enclaves. With Always Encrypted, a SQL client driver encrypts the data inside the client application before the data is even sent to the server. As a result, when the data enters the database system, it's already encrypted. Therefore, even high-privileged users, such as malicious database administrators or rogue cloud operators, cannot access the data in plain text. However, until now, these strong security guarantees were associated with unwanted side effects. Namely, since the database engine had no access to the data in plain text, it couldn't perform any computations on the data. Therefore, the functionality available in queries on encrypted database columns was dramatically reduced, forcing developers to move and process the data on the application side. The emerging enclave technologies enable us to address this hard problem. Think of an enclave as a protected region of memory that appears as a black box to the containing process and the operating system. There is no way to access the data or the code inside the enclave from the outside. Thus, an enclave provides a trusted execution environment for processing sensitive information. And Microsoft Azure is the first cloud making enclaves available to customers as part of the Azure Confidential Computing Initiative. So how do enclaves help customers using Always Encrypted? As you can see in the diagram, we have modified the database engine so that it delegates computations on encrypted database columns to the enclave, which can safely decrypt the data and perform rich computations such as pattern matching or range comparisons. This unlocks Always Encrypted to new scenarios, for example, to applications that process large amounts of personally identifiable information, which often require rich query processing capabilities inside the database. The enclave support also dramatically simplifies management tasks, such as initial data encryption or key rotation, which now don't require any data movement and can be performed in place inside the enclave. At the same time, Always Encrypted continues to provide unparalleled assurance for customer data confidentiality by ensuring that no attacker, not even rogue Microsoft employees, can access customer data. We are really excited to bring this game-changing technology to you, and it is now available for you to try and test as part of the Early Access Preview program. Returning to our diagram, the next layer of security is about controlling access through authentication and authorization at both the application level and the database level. For application access control, Azure SQL Database offers programmability features such as row-level security or dynamic data masking that allow you to implement data access policies for all your applications in one central location, namely your database. To control access at the database level, Azure SQL Database offers multiple features, multiple capabilities, but one particular area which has seen a lot of investments over the last few years is Azure Active Directory authentication. It allows you to connect to your database using identities in Azure Active Directory, which enables password-less single sign-on and central identity management across your application stack. The latest enhancement to Azure AD authentication is universal authentication, which unifies several authentication methods, adds support to Azure AD guest accounts, including Outlook and Gmail accounts, and enables multi-factor authentication. Let me show you how it works in SQL Server Management Studio. Using SQL Server Management Studio, I will connect to my database in Azure SQL DB with my Gmail account and two-factor authentication. First, I need to select Universal Authentication, and then I need to enter my Gmail account name. I also need to provide the name of my Azure Active Directory tenant, which my Gmail account is associated with as a guest user. Once I click Connect, I'll be prompted to provide a password for my Gmail account. Now, since multi-factor authentication is enforced for my Azure AD directory, I have to go through the multi-factor authentication process. So I have just received an access code on my cell phone, which I will need to enter in order to complete authentication. Okay, and now I have successfully connected to my database in Azure SQL DB using my Gmail account and two-factor authentication. The outer layer of security is about activity monitoring and managing security in your database environment. These tasks are inherently difficult, and they usually require a lot of effort, expertise, and experience. But in Azure SQL Database, security monitoring and management becomes easy with intelligent database features that are designed to be used by non-security experts. One example of such an intelligent technology is threat detection, which analyzes your database audit logs on the fly and automatically detects and raises alerts on potential attacks, such as SQL injection or brute force attacks. These alerts are surfaced in dashboards and reports in central tools like Azure Security Center or Microsoft Operations Management Suite. Our newest intelligent security technology is vulnerability assessment, which currently is in preview. VA scans and validates the configuration of your databases against a set of rules based on the best practice and requirements from multiple regulatory bodies. Let me show you how easy it is to use vulnerability assessment and threat detection. What I'm sharing here is Azure Portal, and in the portal I have already opened the vulnerability assessment blade for my database. And what you are looking at here are the results of the recent vulnerability assessment scan, which includes the high-level information, such as the number of security checks that have passed successfully, the number of failing checks, as well as the overall risk summary for my database. In the lower part of this window, we can view the list of all security rules, all security checks that have passed successfully, and the list of failing checks. If we double-click of any of these failing checks, let's pick this one as an example, we can see the detailed information about the risk that is associated with this failing rule, as well as the actionable mitigation steps that we can take to mitigate the issue. In this particular case, this rule, this check is encouraging me to enable threat detection in my database and it's failing because threat detection is not enabled, and the configuration baseline for my database requires that threat detection is enabled. So here we can quickly mitigate this problem by following the remediation guidelines here, which include this link. This link brings us to another page, another part of the portal, where in the single click of a button, we can enable threat detection to ensure that on subsequent scans, this issue is not flagged by vulnerability assessment. Now, once you enable threat detection, you will start receiving notifications about potential security attacks and potential security issues in your database. And you can view these alerts in the other part of the portal. So let me show you that. Okay. So here we are looking at a few security alerts that threat detection raised before for my sample database. Let's look at the details of one of these alerts. So in this example, threat detection reported that somebody has tried to brute force a password for my database. And I can see the details such as the IP address from which this potential attack originated. And also I'm provided with with recommendations on how I can mitigate this issue. So as you can see, vulnerability assessment and threat detection are very easy to use. You do not have to be a security expert to detect and mitigate security vulnerabilities or potential security attacks. Let's go back to our security layers for the last time. In this short presentation, I've given you a quick overview of the latest innovations in the security space in Azure SQL Database, including technologies for data encryption, access control, and security monitoring and management. The SQL team continues to work really hard to ensure that you can easily and effectively secure your data in Azure SQL Database at a time when data protection is more important than ever. Here are a few additional resources you can go and check, including the SQL Server security blog and our documentations and public documentation site. You can go there and learn more information about these and many other features in the security space. Thanks a lot for watching.